Hello dear students, here I am Dr. Amjad Ali. In this video we are going to learn an interesting topic, that is rank correlation. Dear students, in real life data, when sometime we have not accurate measurement for any variable, then we have to make the rank of such type of variables. So after ranking those variable, and when we find the correlation of that particular variable or variables, this is called the rank correlation. Okay, let's start the definition of this rank correlation. Sometimes the actual measurement of accounts of individual or objects are either not available or accurate assessment is not possible. So under this situation, we have to arrange in these objects or individual in order to some characteristics of interest, and such an order arrangement in order is called a rank, and the order given to an individual or object is called the rank. So when you find the correlation of that ranked data, this is called the rank correlation. Okay, let's start the derivation of rank correlation, which is very interesting and full of derivation and full of equations here. So let we have an object be ranked with respect to character. We have a character A, and the observation of A, x1, x2, so on, xi, and so on, xn, and another character that is B, and we have the B observation y1, y2, yi, and so on, yn. Okay, here we have to assume that no two or more objects are given the same rank. Then obviously xi and y1 are the same two numbers from 1 to n. So keep in mind, when two or more objects are given the same rank, then technically they are equal to each other. Okay, since both xi and y1 are the first n natural number, therefore we have summation x and summation y is equal to each other. So summation x started from 1 approaches to n, so like that summation y started 1 to approaches n. So this means that I is equal to 1, 2, 3, so on, n. So this factorization, sum of the factorization is n summation n into n plus 1 divided by 2. Okay, if we take the square of x, then square of summation x square is equal to summation y square, and like that we have I square x1 1 square plus 2 square plus 3 square, so on, n square. So the factorial answer of summation x square or summation y square is equal to n into n plus 1 into 2n plus 1 divided by 6. Now we have summation xi minus x bar square. So this means that if y is equal to x and x square is equal to y square, then x square xi minus x bar square is equal to y minus y bar square. So its outcome will become summation y I square minus summation y I whole square divided by n. So this shows that the factorial answer of this part is equal to n into n plus 1 into 2n plus 1 divided by 6 minus n into n plus 1 square divided by 4. So see, here we have summation y square. So this is the summation y square answer. So we put it here on summation y square and minus. So we have the summation y square. So that's why we are taking the square of this part and then divided by n. And this n will be cancelled out by the square of this n. So that's why we have only one n here, and here we have 2, so that's why a square of 2 is equal to 4. So this means that if you are taking either x minus x bar square or y minus y bar square is equal to n into n plus 1 into 2n plus 1 divided by 6 minus n into n plus 1 square divided by 4. So taking the LCM of this, we get, by solving this, we get n into n square minus 1 divided by 12. So let denote the difference in rank assigned to ith individual or objects, that is d. Now suppose that d is equal to xi minus yi. So this means that if we take the square of the d square, then the right hand side part will become summation n, summation I is equal to 1 n into xi minus yi square. Okay, let's solve this square. So we get summation xi square plus yi square minus 2xy. Okay, now we have summation xi square plus summation yi square minus 2 summation xi yi. Now you have to put the summation xi value here and plus summation yi value here. So see, here we have x value, so x square value is this, and like that we have the summation y square value is also this, because we have summation x square is equal to summation y square. So that's why we have to put this value in place of x square and at the same time on this value of y square. So we get, this is, so substituting summation I square plus summation y square, we get summation di square approaches I is equal to 1 approaches n. So we put it summation y square, I square, summation x square and summation y square minus 2xi y. Now we take if we take the LCM of this part, then we get after taking the LCM, or you can here we are going to calculate summation yi xi and yi. So if we take this part to the other side of the equal, then this will become positive and d will be written on the right side of the equation, then it will become minus. So we get this part. So after the solution, after taking the LCM or after solving this equation, we get summation xi is equal to this equation. So this is known as the product movement coefficient of correlation between the two sets of ranking. Now we have the simple correlation formula, we have the not simple correlation formula, we have the formula for correlation when we have x and y, two variable here. So let's see, here we have summation xy and we have summation x and summation y, and here we have summation x square minus summation x whole square divided by n, and this part we have found that is equal to each other. So that's why, and the outcome of this is also equal to n into n square minus 1. So after putting the values, we have here summation x value is this, we put the summation xi yi value here and minus summation x value and summation y value, we get this. So see, here we have the summation x value and minus this part value divided by n, here we get 4, and this part, both summation x square and summation y square part is equal to n into n square minus 1 divided by 12. So you see this I want to show here. So this is the part which is equal to n into n minus n square minus 1 divided by 12. So here we get this. So we have to solve it, this part. After the solving this part, after simplification and the holds, so see here we have same part, but this 12 is multiplied by both this and this, and this is the denominator for this part and this part, so that's why this part will be cancelled out, 1 minus and this 12 will be multiplied by this, and this 2 will be cancelled 12, and we get 6. And after the solution of this derivation, we get rs is equal to 1 minus 6 summation di square denominator n into n square minus 1. So here we have to keep certain things in mind, that what is the interpretation of this formula. This formula is usually denoted by rs, because we have to make the distinction between this group correlation and simple correlation and rank correlation. So this is known as the Spearman coefficient of rank correlation. Okay, here we have to keep the certain things in mind, that it is to be noted that summation d has least value is 0 when numbers are in complete agreement, and when numbers are variables are not in a complete agreement, then we have the d square value is equal to n into n square minus 1 divided by 3. So substituting these values into the formula, we see that r is equal to 1 for if d I square is equal to 0, and if d I square is equal to n into n square minus 1, then rs rank correlation answer must be minus 1. So this shows that the rank correlation answer lies between minus 1 and plus 1, which is same as the simple correlation or group data correlation outcomes at the same time. Okay, now we have an empirical example of the rank correlation. Now we have to find the rank correlation of empirically. We have a x variable which have the 10 observation, and we have a y variable which have 10 observation at the same time. Okay, here we find the necessary summations or necessary calculations. We have xi and yi, and we have the rank correlation formula. Rs is equal to 1 minus 6 summation d square divided by n into n square minus 1. So first we have to find the d, and then we take the square of the d. So d is equal to summation xi minus yi. So we have to minus xi minus y. Xi minus y. We get minus 1, minus 2, 0, 3, minus 2, 1, minus 1, minus 2, 3, 1 and 0. But we have to take the square of this part. So we take the square of the d. Okay. Now we have to put these values, this value into the formula of d square, and we have here total number of observation is 10 into 100 minus 1, so we get 99, and we get the correlation coefficient of rank correlation is equal to 0.8, which is plus. Okay, let's see the interpretation of this part. Okay, point 8 explains that 80% variation in y is accounted by x, or 80% variation in x is accounted by y. So this is a high degree of relationship between x and y. So moreover, this is a positive relationship And keep it in mind that there is no concept of independent and dependent variable while studying any type of correlation. Either you are studying simple correlation, group data correlation, or you are studying the rank order correlation. Okay, we have another concept related to the rank correlation, that rank correlation for the ties. And sometime in real data we have some observations are same. So when we have some observation same are repeated values in our series, then rank correlation cannot be applied. So for this, Spearman presented another concept. This is known as the rank correlation for the tie. Okay, Spearman coefficient of rank correlation, simple rank correlation apply only when there is no ties available or present in the data. Okay, in this case there are ties in rank. The ranks are adjusted by assigning the mean of the rank which the ties, objects or observation have that were ordered. Okay, for example, if two objects or observation are tie, like we have a fourth and fifth observation are same here, so fourth the rank of 4 and 5, we get the mean value of 4 and 5. You have to add 4 and 5 and then divided by 2. We have to put 4.5 on place of both rank 4th and rank 5th. Okay, the sum of adjusted rank remain as n into n plus 1 divided by 2. But keep it in mind that in this case, previously you have gone through that summation xi minus x bar is equal to each other in rank correlation. But when there is ties or same observations are available in a series, then this will not be equal to each other anymore. So you have to make some adjustment for this for getting the correct solution. So normally rank correlation are also attached for finding the autocorrelation, which is very advanced, and we will cover in another topic how can we find or solve the autocorrelation in the data. Okay, when we have so this will that when we have a tie or same observation in the series, so this is normally also called the autocorrelation. Okay, it has been shown that set of ties involving t observation reduce the value of d square by a quantity equal to 1 over 12 into t square minus t cube minus t. In such a situation, one of the following two methods are said to be used. First method is that you for each tie add a quantity 1 over 12 into t power 3 minus t to summation d square before substituting the value in the Spearman coefficient of rank correlation in order to adjust the formula for the tie observation. You can use it. The second method is use the product movement coefficient of correlation to find the correlation between the two sets of adjusted rank. So these two methods can be used for finding the rank order correlation if there are ties or there are some same observations in your data series. So let's see the empirical example for the rank order correlation in the presence of some ties. We have two members of selection committee, rank 8 person according to their sustainability for promotion as follow. Let's see, we have a person A, B, C, D, E, F, G, H, and members are given rank 1, 2.5, 2.5, 4, 5, 6, 7 and 8, and the member 2 rank 8 A with 2 and rank B with 4, C with 3, 1, D with 3 and E with 6 and F with 6 and G with 6 and H with 8. So see here we have a tie here B in in member 1 case we have a tie between B and C, and in member 2 case we have a tie between E, F and G. So let's solve this equation. Here we have to okay, here we told you that B and C have a tie for the first member and E, F, G for the second member. So this is called this is known as T is equal to 2, and here we have a 3 ties, so this is T is equal to 3, second ranking. Okay, therefore the quantity to be added into summation D square in the formula of summation D, in the formula of rank correlation D square, we have the formula here 1 divided by 12. So T, here we have T is equal to 2, T is equal to 2, so that's why T Q minus 2, and in second part we have a T is equal to 3, so T Q minus 3 is equal to, we get the answer of ties is equal to 2.5. So here we have the rank correlation coefficient formula is equal to 1 minus 6 summation di square divided by n square minus 1. So when you have a tie or some same observation in the data, then the rank correlation formula become as 1 minus 6 into summation di square plus ties. So this is the answer, this is the tie answer 2.5. So you have to add 2.5 in summation D square. So we have to find the D. First we have to find the D, and this is the D, and then take the square of the D and then put this outcome into this formula, and this is the D square and this is the tie answer. Okay, now we have the calculated standard, you can say it rank order correlation. Here we have 0.869. so after some necessary calculation or necessary calculation with the help of calculator, we get rank order correlation is equal to 0.869. So here we have the main concern about the interpretation of the rank correlation here. Okay, see, we have a if we round up this value, this is equal to 0.87. Explain that 80% variation in member 1 is accounted by member 2, or you can say that 80% variation in member 2 is accounted by member 1. So because we have no concept of independent and dependent variable, so that's why we give the interpretation as the first time you use for the member 1, and in the second time you have to use first as a member 2. Okay, this is a high degree of agreement between member 1 and member 2. Moreover, there is a positive correlation between member 1 and member 2. Okay, here we have an alternative method for finding the rank correlation, because in previous session I highlighted that there are two methods for solving the ties rank order correlation. So first we have solved, and now we have a second method. Okay, here we have data, and the formula for finding the rank order correlation for the ties, now it is R is equal to summation xi yi minus summation xi summation yi divided by n, and summation xi square minus summation xi whole square divided by n, summation y square minus summation yi whole square divided by n. Now we have to find the x square. Sum of x square is equal to this, and sum of y square and sum of y square is equal to this, and this is our xi yi series, and sum of xi yi is equal to this. Now we put these necessary summation into the correlation formula and we get 0.896. So uh, with same data, by using another method we have a high correlation as compared to the previous method. So more important interpretation here, 0.89 explain that 89% variation in member 1 is accounted by member 2, and or you can say that 89% variation in member 2 is accounted by member 1, and because we have no concept of independent and dependent variable here, so this is a high degree, this shows that there is a high degree of agreement between two members, member 1 and member 2, and moreover this is a positive correlation between member 1 and member 2. So this is all about rank correlation. Okay, see you with another video. Ciao.